So let's do another example. Square root of x equals -1. So we just talked in the last video about if one side of the radical is square rooted, we can solve by squaring both sides. So I'm going to start this one by squaring the square root of x and squaring -1. So when you square the square root of x, you just get x. When you square the -1, you get 1. So our solution is 1. Let's go back and put that into the problem we started with. The square root of 1 equals -1. Is that a true statement? If you take a number times itself, could you get -1? And the answer is no. This is not true. So even though we solved this correctly and got a solution, the solution doesn't work. And when that happens, we call this one an extraneous solution. So a solution that is solved correctly, you found it correctly, but it just doesn't work in the original problem is called an extraneous solution. So that means what I had here wasn't really a true statement to begin with. So let's do an example of one like that. Let's start with this one. X minus 4 equals square root 2x. So see on the right side of this problem how I have a square root. So that means I can start the problem by squaring both sides. I'm going to square the right side, and to square the left side, I have to square the entire binomial. So that means now on the left, I have x minus 4 times x minus 4. On the right side, the square of the square root of 2x is just 2x. So now on the right side, I'm going to multiply. So I get x squared minus 4x minus 4x plus 16. And on the right side, I get 2x. So now the only way to solve is to set it equal to 0. So I'm going to subtract 2x from both sides. So on the left side, I have x squared minus 4x is minus 8x minus 2x is minus 10x equals 0. So now that we have an x squared problem, the way we need to solve is by factoring. So the answer would be x minus 8 or x minus 2. So x is 8 and x is 2. Let's go check those answers and see if what we get actually works out to be something that is right. So let's go back to the original problem. I'm going to start by putting an 8 right here. 8 minus 4 equals the square root of 2 times 8. So all I did was take my first answer and put it back in for x. Well, this would be 4. 2 times 8 is 16, and the square root of 16 is 4. That's true. So 8 must be a good solution. Let's try our other solution, the solution of 2. So I'm going to see if 2 minus 4 is equal to the square root of 2 times 2. 2 minus 4 is -2, and the square root of 4 is 2. This is not a true statement. So that means that even though I solved this correctly and got the answer 2, 2 is not a good solution. It must be extraneous. So the only solution that works in this case is the number 8. Sometimes you can solve, get 2 answers, and both answers are good. Sometimes you can solve and get 2 answers and only one answer is good. Or sometimes you can solve and neither answer are good because both of them are extraneous. In our case, only one of them was extraneous. Let's do another example like this one. Let's try this problem. Example 2. The square root of x, add 1, equals the square root of x plus 9. So, and since the right side of the equation has a square root, I'm going to square both sides. So on the right, I just have x plus 9. On the left side, I'm going to have to write this out twice. So when I multiply the square root of x times the square root of x, I just get x because it would be the square root of x squared. This would be plus the square root of x plus the square root of x plus 1 equals x plus 9. So I'll put my like terms together on the left side. So I have x plus 2 square root x plus 1 equals x plus 9. And then I want to get my radical by itself, so I'm going to subtract x from both sides and subtract 1 from both sides. So I get 2 square root x equals, and the x's cancel, and I just get 8. So now I want to get rid of the square root by squaring both sides. So I'm going to square this side and square this side. Notice this is multiply, so I can square the 2, which is 4, the square root of x, which is x, equals 64. Divide both sides by 4, so x equals 16. Let's go check that and see if it works. So I'm going to have, on the left side, the square root of 16 add 1, and I want to see if that's the same as the square root of 16 plus 9. The square root of 16 is 4, add 1 is 5. 16 plus 9 is 25, square root of 25 is 5, so 16 is a good solution. In this particular case, we didn't have any extraneous solutions. We only had one solution, and it was actually a good solution. Let's do one more problem like this. Let's do this one. The square root of x subtract 1 equals the square root of 10x minus 10. So I'm going to start by squaring both sides. And remember, when there's a minus or a plus, we have to put it in parentheses and write it out twice. So over here, square root of x times square root of x is just x, minus the square root of x, minus the square root of x plus 1 equals 10x minus 10. So I'm going to add my like terms together. And then I'm going to get the square root part by itself. So I'm going to subtract an x and a 1 from both sides. So I get negative 2 square root x equals 9x minus 11. So the next step then would be to get rid of that radical by squaring both sides. So over here, I square the negative and get a positive. I square the 2 and get 4. Square root the square root of x and I get x. And then I have 9x minus 11 times 9x minus 11. So 4x equals 81x squared minus 99x minus 99x plus 121. Then I want to set one side equal to 0. So I'm going to subtract the 4x from both sides. So I get 0 equals, and I'm going to put my like terms together. So 0 equals 81x squared. Negative 99x, negative 99x, and negative 4x is negative 202x plus 121. I don't know if this one factors. I don't even want to try it. So I'm going to do the quadratic formula. To find x, x equals the opposite of b plus or minus the square root of b squared minus 4ac over 2a. Now I'll have to use my calculator for this. So 202 plus or minus, this becomes 1600, which is nice, because the square root of 1600 is 40. So I have 202 plus 40 divided by 162 and 202 minus 40 over 162. So this is 121 over 81. and this one gives me 1. So there's my two solutions. I'm going to go back and check 1 first. So I've got square root of 1, subtract 1, equals square root of 10 times 1 minus 10. Square root of 1 is 1, minus 1 is 0, and this would also give me 0. So 1 is good. The solution is good. I'm going to try 121 over 81. So I've got square root of 121 over 81 minus 1 equals 10 times 121 over 81 minus 10. 121 over 81, that's 11 ninths minus 1, which is 2 ninths. And I'm going to see if that's equal to the square root of this, and that would be 1210 over 81 minus 10. This is clearly a number bigger than 1. Subtract 10, so this is going to give me a negative number, and this is 2 ninths. These are not the same, so 121 over 81 does not work. This one's extraneous, this one's not, so my only solution is the number 1.